morning, dear friends. In the last class, we have learned about what is the difference between bipolar junction transistor and the power diode, as well as what is the difference between bipolar NPN transistor and the PNP transistor. In this today's session, we are going to learn about how the construction and working of the MOSFET or metal oxide silicon field effect transistor, and what are the different types of metal oxide silicon field effect transistor, and how that simple normal electronics low power metal oxide silicon field effect transistor is working, and how the construction of high power metal oxide silicon field effect transistor. Especially we are going to learn in this course n channel metal oxide silicon transistor only. The reason behind this is normal applications n channel metal oxide field effect transistor only people are using due to the high mobility of the electrons. So let us go to the points one by one. What is meant by metal oxide silicon field effect transistor? Already I have explained MOSFET is nothing but metal oxide silicon field effect transistor. So this is the combination of the concept behind field effect transistor and the metal oxide silicon structure. So this structure having two combination of one is field effect transistor as well as another one metal oxide silicon structure. Normally, as like this bipolar junction transistor, this metal oxide silicon field effect transistor also is helpful to amplify the electrical power or maybe electrical voltage, or we can control the increase or decrease, everything it will be possible by using this metal oxide, this type of circuit as well. So normally this metal oxide silicon field effect transistor as well as bipolar junction transistor also use helpful for amplifying the electrical circuits, electrical power in the circuits. Then this metal oxide silicon field effect transistor having three terminal: source, gate and the drain. Source, gate and the drain. So in this case, drain and source are the power terminal and the gate and source are the control terminal. Then types of MOSFET. Normally the types of MOSFET, as I told already, there is having two types of MOSFET, n channel MOSFET and the p channel MOSFET. Normally this is enhanced type, so that's why we will call it as n channel enhancement MOSFET and p channel enhancement MOSFET. But this course is not only concentrating n channel MOSFET. The reason is this n channel MOSFET is having high mobility of electrons. That's why majority of the applications n channel MOSFETs are very much helpful. Then it is the unipolar device and that is not having a secondary breakdown as like the bipolar junction transistor. The bipolar junction transistor is bipolar. Name itself we can say bipolar. Two poles are there. That means there is, if you go through the previous videos of the construction and working of bipolar junction transistor, you will come to know there is a possibility of electrons movement as well as the holes movement. Both are there. That's why bipolar. Here only electron movement only. That's why we have called it as unipolar. And as like bipolar junction transistor, this metal oxide silicon field effect transistor is not having the secondary breakdown. Let us see this construction of n channel and p channel. Already in the starting of the power diode, I have explained what is mean by n plus, what is mean by p plus, what is mean by n minus, everything. So n plus is nothing but high mobility of electrons. More electrons are doped there. So p subtract is normally like a p layer. It is having more number of holes. So n plus is having more number of electrons. P is having more number of holes. So now n plus one n plus is connected to the source and another one is connected to the drain. So this gate also having the partial connection in the n plus as well as n, this 2n plus, so gate. So in between this gate and the body of this semiconductor, there is having silicon dioxide, that is a insulating material. I will show in the next slide how the insulation material is placed in between gate and the body of the semiconductor. So at the same time, this MOSFET, p-channel MOSFET, this p-channel MOSFET, we are, instead of n channel, n plus, we are having p plus. P plus means more holes. Then n means nothing but more number of electrons as well as like normal n layer. Then P is connected to the source, then P plus also connected to the drain. Here also silicon dioxide is placed. I will show in the next slide. Then if you see here, this is drain and source, and we can see this arrow mark of the n channel MOSFET is towards here. That means current is flowing from source to drain, not drain to source. That's why this arrow mark is like this. At the same time, p channel MOSFET, arrow mark is away from this. That means current is flowing from drain to source, not source to drain. So that's why we have this arrow mark towards this n channel, and p channel arrow mark is away from this. Then if we go to the working of this n channel, normal simple n channel MOSFET, here I already told you n plus is nothing but highly dot, and p is having more number of holes. And if see here, the silicon dioxide is connected, one slab is connected in between this. If you see, this gate is not directly connected to the body of this p type, so that there is having one insulating material is connected. So this current flowing through the gate is directly not controlling by this it is not controlling the entire metal oxide silicon field effect transistor. Instead of that, there will be a voltage will be generated in between this gate metal, this metal and this body of the semiconductor. So this voltage is helpful to control the electron flow. That's why this metal oxide silicon field effect transistor is nothing but voltage control device. At the same time, bipolar junction transistor, the current flowing through the base directly controlling the electron flow. That's why it is current control device. Here, this due to the presence of insulating material, due to the voltage generation, the voltage is controlling the electron flow. Let us see how the electron is flowing and how the conduction is happening. See here, voltage across the gate terminal is positive with respect to source. That means source is negative and gate is positive. Similarly, the voltage across drain to source, drain is positive with respect to source through the load. We will connect the load across the drain to source. Already I told you, drain and source are the power terminal, gate and source are the control terminal. So now we assume that gate is open. We have not given any supply to the gate. So what will happen? Here drain is positive and source is negative. This positive will attract all the electron of the n plus, since n plus is nothing but high mobility of electrons. So this all the electrons will be passes through this. Why? This will be create this junction automatic. That what junction? P subtract and n plus junction will be automatically reverse bias. So there is no current flow will happen. So though no electron flow will be happen from source to drain or drain to source, therefore there is no current flow between source and drain. That means why here it is positive, here with the electron, so it will be attracted. So this two layer junction between P and the n plus will be reverse bias. Now assume that the gate terminal is switched on, there is a switch is closed, so that this positive terminal will be connected across this. So now due to this there will be a voltage will be generated. This voltage generation polarity will be upper side will be negative and the lower side will be positive. So due to the positive, this electron already this junction will be for this, here it is negative. This negative will be repelled by this. So negative will repel the electrons. So this electrons in the n plus layer will try to move here, move towards this. But this junction is already reverse bias, right? Reverse bias. So due to this positive, this holes will be repelled. At the same time, these electrons in the n plus will be flows through this. So this electron flow will happen between to source to drain, electron flow. Therefore, the conventional current flow will taken from drain to source. So if we increase the gate voltage further, automatically the voltage across this this gate and the body of this semiconductor will increase. So this voltage will helpful to attract more the electrons. So likewise the current flow can be controllable. So likewise, so if as the current flow is this direction, we can see current flow direction is source to drain. That's why in the previous slide I have shown here arrow mark is towards this source to drain. So electron flow is flowing from source to this side. Current flow is flowing through opposite side. So opposite side means current flow in the outside will be source to drain. Then now I hope you understand how the simple NPN transistor, NPN bipolar metal oxide silicon field effect transistor is working. Now we are going to learn about construction and working of power metal oxide silicon field effect transistor. That is normally for high power devices. All the many number of metal oxide n channel MOSFETs are connected in parallel, or it is diffused in this diffused manner it is placed. So that's why then only we can use high current rating will also increase, as well as voltage rating will be also increase. So now in this case we can see here n plus layer, this is the drain, already metal, and here source is also connected to the metal. Source, two sources are, and the gate terminals, negative terminals are connected together. So this will be VDD. Through the load we have connected to the drain. Then this gate terminal, gate here it is positive. So this gate and the source are the control terminal, and this the source and the drain are the power terminal. So now this is N negative layer is highly resistivity, having high resistivity. N positive layer is high conductivity. So this high resistivity layer will help you to determine the voltage blocking capacity of the power MOSFET. Voltage block capacity of the power MOSFET. Let us go to the operation. As like previous, assume that there is a gate terminal is open. If the gate terminal is open, already P layer here, this is the negative. Negative is connected to here. So, but due to this drain positive, this positive and this electron in the high conductivity layer will be attracted. Therefore, this N plus and the P negative layer will be also reverse bias. So there is no electron flow between drain to source or source to drain. Right? Then now assume that now we are giving, gate is closed, we are giving positive supply. So when we give this positive supply, what will happen? There it will generate one voltage. Here negative, here the below positive. So due to the positive, high electrons, these electrons will be attracted by the positive terminal. Therefore, this junction will be forward bias. So therefore, current will flows through like this. Electron will flows in the opposite direction. So current will flows through this. Similarly, another one parallel path will flows through. So this is the current flow direction. Current will flows. So this, due to that, current will flows from source to drain. So likewise this working will be. So what is the difference between normal simple simple MOSFET and power MOSFET is, there is power MOSFET is having more number of simple MOSFETs are connected in parallel. Moreover, there is having a N negative term high resistivity layer to increase the determine the voltage blocking capacity of the power MOSFET. I hope you understand the operation and working and types of simple MOSFET and the high power MOSFET. Next class we will learn about characteristics of the power MOSFET. Wish you all the best. Thank you.